Hey gang, so this is my honors class homework. Alright, so I'm going to put the problem under here, and then I'm going to work it on my iPad. It's just a little easier for me than trying to go through a bunch of stuff. Alright, I'm going to start with number 14. This is on lesson 2-1. And I'm looking at number 14. Alright, so number 14 says, hopefully you have your homework there. I will put it under here a little bit. Let's represent Gupta's age. You can solve the equation, and I'm going to write it on here. 2g minus 5 plus g equals 31. Alright, so remember we talked about those properties. And we're using this, and it's like, which property would not be used to solve this? So on A, it's got addition property. On B, it's got commutative property. I'm just going to put com. C is division. And D is subtraction. So let's see if we can rule out some of these. If I were going to solve this, I think the first thing I would do would be to combine like terms. Combining like terms is kind of like our commutative property because we're just rearranging it and we're putting them together. So I'm definitely going to be using that. I would add 5 to both sides, right? So that means I'm adding. And in the end, wouldn't I have to, I'm going to end up with this. I'm going to have 3g equals 36. Wouldn't I have to divide in order to get g alone? So that would mean I would be dividing. The only one I'm not really doing, is D, which is the subtraction. I didn't have to use that at all. So which one did I not use? I didn't use subtraction. Okay, I can't remember which ones I assigned y'all, so if somebody texts me and let me know, I'll be great on the Remind app, but up until then, I'm just going to kind of wing it and say, well, I'm not really sure. I'm just going to kind of work a few of these. 17, the solution to 3x plus 15 is, here we go. The solution of 3x plus 15 equals 6 is shown below. So here we go. They've shown this. Which property justifies step 1 in the solution? Oh my goodness. Okay, so original equation, what did they do here? They are subtracting, right? Aren't they subtracting there? So I would say, I think I would probably say subtraction property of equality because they're subtracting. Yeah, pretty straightforward there. 18. To solve this equation, 3x minus 7 equals x minus 2, Alex says the first step is to subtract x from both sides. Okay, I'm going to put this over here. So I got crazy things on there. Let me clear this slide. Alright, to solve these equations, he says the first steps is to add both sides. Okay, so this is number 18. Alright, A. A says solve the equation using Alex's method of first subtracting x from both sides. So let me write this here. 3x minus 7 equals x minus 2. Alright, so this wants me to first solve this using Alex's subtracting x from both sides. So I'm going to subtract x from both sides. And y'all can see I just kind of work these the same way y'all do. I mean, there's no like magic or anything I do on this. 3 minus 1 will be 2x. Minus 7 equals negative 2. Then I would add 7 to both sides. So 2x would equal 5. And then I'll divide both sides by 2. So I am going to get a little bit of a fraction here. And x is going to equal, I'm just going to put 2.5. Normally I would really leave that as a fraction. It doesn't matter, either way. So solve the equation using Alex's method first. Okay, now solve the equation using Danny's method of first adding 7 to both sides, okay? So now let me come back up here. 3x minus 7 equals x minus 2. All right, so let me solve this using Danny's method. By adding 7. Gonna subtract x. So 2x equals 5. Divide by 2 is pretty much the same thing. X equals 2.5. All right. Who is correct? Alex or Danny's? Justify your answer. Well, they're both correct, aren't they? I'm just going to say they're both correct. It doesn't matter. I could say something about the commutative property. It doesn't matter what I do first. Subtraction property, addition property. Either one, they're both going to work. Is there another correct first step for solving this equation? If so, identify another first step that you could do. Well, let's see, we did the one with subtracting. What if we began by adding, do you know where I'm going with this? I'm going to circle it. I'm going to do it in blue. What if I began, instead of doing, I did the 7, I did the x. What if I started right here and did it by adding 2 to both sides? So I guess that is D. I could start by adding 2 to both sides. That would be the same thing. I would still get that same answer. There's not anything different. I'm pretty sure I gave you guys 19 as well. So let me just look at 19. Jordan has been offered 2 summer jobs. One job is at the mall and pays $7 an hour. The other job is with the neighbor who will pay $50 per week plus $5 per hour. How many hours per week would Jordan have to work for both jobs to pay the same amount? Okay, this is just like that LA Fitness job we did, or problem we did. So let's remember, whenever we saw this, remember how we set them equal to each other? So he's been offered 2 summer jobs. One job is at the mall, $7 an hour, straight up. $7 an hour. When would that equal this other job, which is paying $50 per week, plus they're going to pay him $5 an hour? Okay. So what I want to do to figure out the question is how many hours per week would Jordan have to work for both jobs to pay the same? Well, take a moment, solve that for x. X is representing the number of weeks, so solve that for x and you'll get your answer on that one. Okay, I don't think I assigned 20, so I'm going to skip that one. You can pause the video now if you're still working. I know I assigned 23, so I think I'm going to go and do 23 next. If I did something between there, I'm sorry. I don't have those. Let's look at 23. Okay, I'm going to try and draw this picture. Oh, hey, that's not too bad. So this is question mark. This is B. This is C. This is A. This is 5x minus 1. This is 3x. Okay, here's the question. Use the diagram to answer parts A and B. All right. Yep. The length of AB is twice the length of side AC. So the length of AB is twice the length of AC. Okay, so this length right here, if it's twice this length, I'm going to go ahead and write it. Well, 2 different ways. I'm sitting here thinking, what way would y'all work? If this length from here, oops, sorry. Stop. Okay. If this length here, I'm going to just scribble it, is double this, some of you would double it in your head and go 10x minus 2. Some of you would say, oh, double is 2 times 5x minus 1. It doesn't matter to me which way you think. You can double it 10x minus 2, or you can think of it as 2 times that. So the length of side AB is twice the length of side AC. Write an expression for the perimeter of this triangle. Be sure to simplify your answer by combining like terms. Perimeter is when you walk around. So I'm going to do this. 2 times 5x minus 1, that's my AB, plus I need to get this other side, 5x minus 1, plus I need to have the little short side, 3x. So I'm going to hippity-hoppity distributive property. 10x minus 2, which we already knew. We knew we were going to double it. 5x minus 1 plus 3x. 10, 15, oops, forgot my x. 10, 15, 18, so 18x. Negative 2 and negative 1 will give me negative 3. All right, so that's my perimeter. The perimeter of the triangle is 78 units. What is the length of AB? Okay, so now we know that the perimeter, which is this right here, is 78 units. I just want you to solve that for x. So 18x minus 3 equals 78. We're going to solve, oh, that really hurt. I just touched my cheek, y'all. Oh, I have a black eye. It's not very pretty. The perimeter of the triangle is 78. What is the length of AB? Be sure when you take this equation and you solve it for, when you solve it for x, oh my goodness, y'all. I didn't ask you what x equals. What did I ask you? Yeah, I asked you for the length of AB. So after you get x equals whatever, you need to take this value and plug it in to your equation. Plug it into that 2 parentheses 5x minus 1 in order to solve that. All right, that was B. I know I did 23. I'm pretty sure the other one I did was 25. Pause your video if you're going to keep going. Otherwise, I'm going to move right on into 25. 25 says a student solved an equation. I'm going to put that equation up here. 5 parentheses a plus 5. While you're reading yours, I'll put it on here. Minus 3 equals 3 times 2 minus a. All right, so we have this equation. The student's solution is shown. If is the student's solution correct? If so, state the property of equality or provide an explanation for each step. If not, identify the error, then write the correct solution. Okay. I'm going to take this and I'm going to move this over here a little bit. And this is 25. I'm going to erase that because I want to be able to get it. Because it's going to be kind of long. Oh. Oh. Hello, let me get that. Okay. So that's my, okay, so let's just go ahead and start labeling it. Here, you know what, let's actually do this. I think this one's going to be a little bit of a mess. So let me do a quick, let me find it. Yeah, I think I'm going to want a picture of this one. All right, so there it is. So I think this will be easier for me. Let me keep it flat for y'all. Okay. So this is, so on this I would write original problem. It's hard to write when I get close to that. Okay, there we go. So now what did they do on this next step? It looks like they did hippity-hoppity, distributive property. Did they do it correctly? Yeah, that looks right. So I'm going to say this is distributive property. Then I'm going to notice that they, looks like they put those together. And they got 22, so that's right. So when we put them together, we say combine, did you need me? Like terms, huh?
Yeah. Not really.
Okay. Now let's see what they did. Looks like they added 3 to both sides over here. So we're going to call that addition. Property of equality. And then they're going to put these together right here and get 8. these together are going to cancel out. So when I put them together, we say combine like terms. So this step, we're going to say combine like terms. Okay, so on this next step, looks like they came to this side and subtracted 6 off. I don't know that that's right, because remember, this is going to be my A side. This over here is my number side. I don't know that I would do that. I feel like you're going to go back in circles. It's okay, we can do that. And probably not the way I would have done it. So when we subtract right here, did you need me? Okay. My son is staring over me. We're going to do subtraction.
Just watching you do algebra.
Okay. Property of equality. So now when we put this together and this together, we're going to say combine like terms. Okay. And now, now they're gonna do this. Now they're gonna move that 16 over here, right? So they're subtracting it from both sides. So we're gonna do subtraction property of equality again. He added an extra step in there. Oh. Subtraction prop equality. So now those cancel out and negative 16 eighths. So now we're going to combine like terms. And, oops, sorry. And he's going to divide both sides by 8 right here. So we call that division. Property of equality. And then he divides by 8 and gets negative 2. So that is simplify. Yeah, I'm good with his answer. That's right. Took a crazy way to get there, but yeah. Let's see. If so, state the property of equality or identify the... Yep, we did all that. Identify the error, then write the correct solution. So he had it right, and we identified everything. So we are good to go on that one. My goodness, that one was long. All right, let me go on. I think the next one I assigned was 27. Let's go here. Oh, I'll go back. Where was I? I was on that one. Okay. Which equation has an infinite number of solutions? Okay, I talked about this in one of my classes. You know what? I think in the other ones I didn't get to this. So this is actually a really good one for us to do. So infinite solutions. So here we go. Let's do 7x minus 3 equals 4. Alright, so I'm just going to solve this. I'm going to add 4 to both sides. I'm sorry, not 4. 3. Oh, hello. Undo. Oh my goodness. Here. I don't even know how I got that on there, y'all. That was like weird. Alright. We're going to add 3 to both sides. So that gives me 7x equals 7. I would divide by 7. And I'm going to get x equals 1, right? Okay, so that's not an infinite solution. That's x equals 1. So now let's try the next one, which is 1/3 x minus 5 equals x over 5. So I'm going to draw my line and solve this one. Oh, that is... There we go. Okay, so you know what? I'm going to get both my x over here. I'm going to actually subtract 1/3 x from both sides. Because this one's kind of a weird one, right? Kind of looks funny. So I'm going to have negative 5 here. Over here, I'm going to have x over 5. Now, let me come over here and just do something real quick. X over 5. That's the same thing as 1x over 5. I can take that 1/5 and kind of move it to the front, and it looks like this: 1/5 x. Same thing as x over 5. The difference is it's like 1/5 times x over 1. X times 1 is x, 1 times 5 is 5, so it looks like that. But I can break it apart so that it looks like that. All right, let me erase this. And so this is minus, actually, no, let me do this. Now that I showed y'all that, I'm going to say 1/5 x minus 1/3 x. Okay. Now we have a calculator. I'm going to grab mine, and it's going to do 1/5 minus 1/3. So it's going to do alpha y equals, and I'm going to do 1 over 5 minus alpha y equals 1 over 3. And it's going to be negative 2/15. So negative 5 equals negative 2 over 15 x. Now I can already tell I'm going to get some kind of answer on this one. I could stop here because I know I'm looking for infinite solutions and this isn't going to be one, but I want to finish this so that you guys know how to work it. I would take it and divide by 2 over 15, divide by negative 2 over 15, and x would equal, and I'm going to go back to my calculator because I have all that in there, right? Negative 5 divided by, I can divide by the answer. And the answer button, I got to hunt for that. I haven't used it in a while. Is second. Oh, there it is. Right there on the negative. Right here on the next. See, ANS. I can hit second answer. So it says negative 5 divided by that answer is 75 over 2. 75 over 2. So again, it's not an infinite number. I got to keep going. So here we go. C. C is 2/3 x equals x minus 5. Now, I could work that one. It's not that hard. Oh, I guess we'll just work it. I was sitting here thinking, oh, I really don't want to work it. I can already tell it's not going to work. Ah, it's okay. Let's subtract 1x. Subtract 1x. 2/3 minus 1 is going to be a negative 1/3 x equals negative 5. I'm going to divide both sides by negative 1/3. And my x is going to equal, I'm just going to tell y'all, positive 15. Okay, we're getting there. We're close. It didn't work for any of those. Oh, I'm out of slides. Next. Why won't you go to my next one? Okay, hold on. Doesn't want to add a slide. There we go. Oh. Oh, I thought it was going to put the thing on there. It didn't. That's okay. All right, so let's do this. Let's look at D. I'm still trying to find that infinite solution. All right, D is 3x minus 2 equals 3x minus 2. Had I really looked at those, I would have seen this one first. Now, infinite solution means that no matter what number I put in, I get a true statement. And in this situation, this side equals this side. It's the exact same thing. No matter what I put in, it's going to be the same. You can also look at it like this. If I were to draw the line, and if I were to add 2 to both sides, I would get 3x equals 3x. Then you're like, huh, well, what if I subtract 3x from both sides? So that's 0 equals, but that's also 0. 0 equals 0. That is a true statement. That means any number works. So when we get this, we say all real numbers works, or we say infinitely many solutions. Like the sky's the limit. Whatever number you can think of, it's going to work. All right. I have no clue which next one. I'm going to say that I probably picked 29. I hope I did. So, my iPad's doing weird things tonight. I'm going to say I probably picked that one. I usually pick the ones that have figures on them. Alright, so let me do this. Let me draw this on here. We've got a rectangle, and we've got another one. Okay, so we've got 2x and m, and we've got x plus 12 and x plus 3. Okay, so the question is, write an equation that states that the perimeters of the two rectangles are equal. Okay, so we need to do the perimeter of these. Okay, well that won't be too hard. I'm going to use red. I know that opposite sides are the same. And this one right here would be x plus 3. I'll just put it right here. So if they're going to tell me that the write an equation that states that the perimeters of the two rectangles are the same, I would say the perimeter of this one. So I would say 2x plus 2x plus m equals 2 times x plus 12. And the reason I'm doing 2 is just I didn't want to double it. And then plus 2 times x plus 3. Could you have written it out like I did this one? Yeah, you could have. It was just easier to do this. I am going to, oh, it doesn't say. I don't have to simplify that. Normally I would simplify that. I think I'm going to go ahead. So 4x plus 2m equals, this would be 2x plus 24 plus 2x plus 6. I'm going to go one more step. 4x plus 2m equals 4x plus 30. Okay, so there's my perimeter. For what values of m will your equation have infinitely many solutions? Okay, so if it's going to have infinitely many solutions, then I need for, I'm going to let you think about that for just 1 second, and I'm going to tell you. Okay, if it's going to have infinitely many, this means these two have to be exactly the same, right? What value would have to be right here for me to get 30? In order for 2m to equal 30, m would have to be 15. So if m was 15, wouldn't I get 4x plus 30 equals 4x plus 30? Yeah, I would. And then that would be infinitely many solutions. So B says for what values of m would it be that way? So this was my A. B would be m equals 15. C, for what values of m will your equation have no solution? Okay, think about that. How would I get no solution? In other words, to get no solution, I need for 4x plus 30 to look something like this. I need for it to be 4x plus something equals 4x plus 30. Unless this is 30 right here, it's no solution. I could put anything I want there. So I could put 6. That's no solution. 4x plus 6 equals 4x plus 30. No, this has to be exactly 30 for there to be any solution. So for what value of m does it not work? Any other one. So any other number. There's infinitely many possibilities that that wouldn't work. The only way it does work is if m is 30. If m is anything else, it doesn't work. For what values of m will your equation have exactly one solution? Well, there's not any. There's not any that'll work because your only option is 15 for infinitely many. It's the only way it's going to work because any other number gives you no solution. So D, there's not any. We're not going to have anything that will work. I'm just going to put nothing works. Alright. Oh, my battery's running low. Yeah, I know. Alright, so, let's see, what else did I do? No, I didn't do any in 2.5 because we haven't done literal equations yet. Okay. Oh my goodness, I don't know why it's doing this to me. Okay, 35. So on 35 it says, you have less than 3 hours to finish your homework. Which one of the following graphs represent this situation? Less than 3 hours. So you don't have 3 hours. This says you have 3 hours. This says you have 3 hours. Here we go. You don't have 3. You don't have 3. You have less than 3. So that's going that way. So D is what I'm thinking. All right. I don't think I did that one. I know I did 40. I remember that. I know y'all are all like, Christine, why didn't you write those down? Well, I did write them down, but I wrote them in my other journal. And then I brought home the wrong one. All right, let me look at 40. Because I know I signed that one. I remember signing that one. Okay, 40. Oh, my goodness. I'm going to try and draw this picture. Y'all ready for this? Y'all be reading it while I'm trying to draw it. Okay, it's not the greatest, but it'll work. 7 minus 5x, 3x minus 2, 3x plus 4, 5 minus 3x, and x. Okay. The question is, Mr. Hernandez has 41 feet of rope to enclose a pentagon grazing area for his sheep. He makes a drawing below. Use the information in your drawing to answer the following questions. All right. Which inequality could be used to find a possible perimeter of the grazing area? Okay. Well, if I'm going to find the perimeter, I'm going to need to add it all up. Now, I'm going to be a little lazy on this because I've got my drawing. I'm just going to go ahead and add all my like terms. 3 and negative 3 are going to cancel each other out, right? Negative 5 and 3x are going to give me negative 2. Did I write everything down right? 3x squared, or 3x4, 5. Oh, I forgot my x. That's what it was. Okay, you know what? Maybe I should let me just stack it. 7 minus 5x, 3x minus 2, positive 3x, and negative 2. Oh, I'm probably confusing y'all. Let me just do this. Sorry. That's what happens when I think about it while I'm trying to work it. 3x minus 2 plus 3x plus 4 plus 5 minus 3x plus x plus 7 minus 5x. Oh, it's not going to fit. I'm going to come over here. Plus 7 minus 5x. All right. Negative 5, 3, 3, negative 3, and 1. So 3x and negative 3x, those are going to cancel each other out. 5x plus that will be negative 2x. Negative 2x plus 1 is going to be negative 1x. Alright, so I used all those. 7, that'll be 5, that'll be 9, that'll be 14, that'll be plus 14. And we've got 41 feet of rope. So I've got 41 feet of rope. So if I stretch it all the way around, can I use exactly 41? Yeah, I could. So I could be equal to, which side needs to be bigger? Can I be more than 41? Or does this side need to be less than 41? Yeah, less than 41. So remember your L's. This makes an L, so it's going to go this way. I need this to be less than 41. So my equation is going to be negative x plus 14 needs to be less than or equal to 41, which if I'm looking right, I think that's B. That's a terrible B, but it would be B. There we go. All right, guys, I hope that helps you with your homework. It took me a lot longer to do that because I was sitting here thinking about it. But anyway, thanks for watching, y'all.